So today we have a hard problem. Let's look at the description. We have numbers, list of numbers, and we have a range, and we want to add some values to these numbers. So the range sum would be at least, or I would tell not at least, but the range should be the maximum of minimum. Let's write some numbers. So we have a list of numbers like this, and we have a range like 2, for example, and the value k is how much we can add totally. For example, 2, and we want from this range, all of these ranges have a sum. So this like 3 plus 4, 2 plus 3, or I'm sorry, I'm wrong. This works a little bit different. So if range is 1, we going from each number, we going up to 1 left and to the right, and then we can tell that for this number the value is sum of this range, 1 plus 2 plus 3, and repeating the same process for all the positions, and also for this tail and prefix and suffix. It has 1 plus 2 for the first number and 3 plus 4 for the last. And if we not change anything, the minimum is the minimum of those values. So 1 plus 2 is 3, and this would be the minimum. And then the second part is we want to add at most k to any of these numbers. So the minimum of the new list would be maximum of all possible. So in other words, we should optimally add these numbers k so how can we approach this? I thought about how can you even add the k numbers. Let's just explore what does it mean to add the number. For example, we add in value to this plus 1. What would change? So this would be 1, 3, 3, 4. We change this range value, and so for the number 2 we change, and it goes like this. Also for the number 3 the value would change. So basically in a range of this, all the values would change by this number. What other properties we can observe? When we add in the value, our minimum sum could improve, could increase, or could stay the same. It can't decrease. So the law is always increasing. Always increase the sum. The second observation is that we have at most k values. What does it mean? We can spread this k to several positions, or we can just add all the k to one position. And let's observe the numbers again. What is the minimum? The minimum is, for example, for this list is this position first. And if we add any value to either this number or any number in the range, if the range is, for example, 2, we increasing this minimum, and the minimum could become some other number, like this, for example, depending on how much we increase the value. So the first idea of mine was to maybe we can look at all intervals, put them in some, I don't know, priority queue, and in a sorted order we just pull the minimum each time, increase the value, and put it back to the queue. But this solution is obviously not very optimal, because when we add the number we have to change full range of numbers, and we should recalculate all the values, that not only the current number but all its siblings to the left and to the right, and the solution just one addition would be of range, and total we have, I don't know, we have n numbers, but when we add how much we add to this minimum, this other question, should we add all the k or some other value? So this is a dead-end intuition. So the other intuition is, if you look at the numbers again, and we know the minimum, like it's 3, for example, we always know the minimum for particular list of numbers, and the minimum is the answer. And we have a budget like k to add, maybe to this minimum, maybe to other numbers. And how much we should add, how much to add, this is a question. Should we add all the k values? Should we add some other value that is a little bit smaller, and then improve the other numbers? So if we look at the numbers like histogram, for example, like this, and the minimum is our answer in this histogram, and when we improve the minimum by adding some k value like this is a new minimum, and this is the answer. And also, and for example, if we have other number that little bit lower, we should add to it too. So this is a target value, and the sum of addition of this should be less or equal to k, no more than k. And that means that we have a condition to check that should be true. And we have a variable to propose, like the target. So if we define the target as minimum, desired minimum is the target. But how much we should desire? We just should desire the maximum possible, and the possibility is enabled by this condition. That means if we have all the possible targets, like target A, target B, target C, and this condition is for, like, if we choose a little target, like very low target, all we can say that this condition is true for every number, because we didn't have to add anything, and it would be true for the low value, then again true, and after some big some like border variable, or I don't know, it becomes false, and then it would be false forever, because very big target is requires us to add too big sum to achieve this target for all the numbers, and this sum would be bigger than k. So this is a binary search. I wouldn't explain it here because it's common knowledge, and this was my intuition, and this is how I solved it. And a little trick you have to understand, or like little corner case. How? Okay, we know that we would solve it with a binary search, but how can I, given the list of numbers like 1, 2, 3, 4, and the target, how I actually can like add the numbers to the target? Because when you add the value to a particular number, you have to check every range, and this operation, given the range, can be up to the length of the array. It can be of n squared, because you have to check every number, and you have to add to any number in this range. So this is a part 2 of this hard problem, and this itself is like a medium problem to solve, how you can add to the range optimally to achieve the target. Let's draw the numbers again. Let's look at the range. For example, the range is 1 to the, it's the current position is it points at number 2, and the range to the right goes to number 3, the range to the left goes to number 1, and we define, for example, the target is 3. Oh, I'm sorry, this is not 3, it's so the current sum is 1 plus 2 plus 3 is 6, and the target is, for example, 7. So we have to add +1 to achieve the 7 from 6. And we can add it to any number in this range. But how to choose which one we should add? So for this, I proposed the greedy lazy strategy. So in my intuition, the optimal way is to choose the rightmost position. Rightmost. Why is that? Because the left values are already checked. We're going from the left to the right. And it doesn't make sense to add to them because they are old values, they're already good, and we haven't, they are not required. But the values to the right are not checked yet, and then they can potentially require additions too. And that means it would be optimal to add to the rightmost position as much to the right as possible. So this is greedy strategy and it works. And to maintain the addition, I just used this temporal array, and then I used like linear scan, and when I do the operation, I just mutate this array. So I have current index, it's the middle. I have right index, it's the right border, and I have left check to remove from the window. So it's a sliding window, and I add in values to the right and I remove in values from the left. Binary search is on a long range because the answer is long, and then I check if the current middle is good. If it's good, I pick this middle and compare it from with previous, so I just pick the best. Then I up the lower boundary because the lowest targets are easy and the highest targets are harder. So I think that's it. Let's look at the hints. To calculate the number of stations, binary search. Yes, it's the same solution, but I think they made it a little bit more optimal than this clone operation. Let's look at, there is no other solution, unfortunately. Okay.